Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over Ottocento number 24, Basic Exponentials. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay guys, so before you watch this video, you definitely want to make sure you've mastered percents. I'm not going to be going over that again, so most specifically, you're going to want to watch the first video in this playlist, which goes over percents, and then my two shorts, percent multipliers and percent change. Those have a lot to do with exponentials, so just make sure you understand those before you start watching this. Okay, so standard form of what I call a basic exponential shows up all the time on the SAT. It is y equals a times b to the x. A is the initial value, which we also call the y-intercept. And b is the multiplier. This essentially just tells us what y gets multiplied by when x goes up by 1. Now, the interpretation of these letters kind of gets messed with if the form of the equation changes. So just note that these two interpretations are only true when it looks exactly like this. There are some other like wrenches and forms, and we'll talk about those either in this video or a future video. But just make sure you're only using this interpretation if it looks exactly like that, y equals a times b to the x. All right, so let's say we have y equals 6 times 2 to the x, and let's look at the graph. So I notice that the y-intercept is 6. That is because in the equation, a is 6. If you made x 0, you would get 6 times 2 to the 0. 2 to the 0 is 1. 6 times 1 is 6. Now, I also notice that when x goes up by 1, the y values are getting multiplied by 2. 6 times 2 is 12, and 12 times 2 is 24. That is because the multiplier, or the b value, is 2. So just make sure you understand what both these letters A and B, what they mean forwards and backwards. Okay, so what a common trope on the SAT is they love to give us a table and they tell you, hey, this is in the form y equals a times b to the x. What's the equation? Well, I noticed that very conveniently, x is going up by 1 and y is getting multiplied by 3. So that tells me that the multiplier, because x is going up by 1 and y is getting multiplied by a number, that number is b. So b is equal to 3. And the initial value, I always get that it's the y-intercept. So I get that when x is 0. So I look at the y-coordinate when x is 0, and that tells me that a is 2. So the equation of this exponential is 2 times 3 to the x. And of course, you could do this using regression. Just make sure that you select exponential regression. And I'll go over this in my Desmos video on automatic regression. It regresses it in the form a times b to the x. So if it were a more complicated form, you would have to type it in manually. Okay, next up we have exponential growth versus exponential decay. Exponential growth looks exactly like this. And as long as everything's positive, that will occur, no negative signs or anything, that will occur when b is greater than 1. And you'll see this phrase on the SAT. They don't usually use the term exponential growth. In the answer choices, they call this increasing exponential. Increasing just means it gets bigger as it goes left to right. And exponential decay looks like this. And that occurs when 0 is less than b is less than 1. So for example, b is 0.25 or 1/3 or 3/4, something like that. Just any number between 0 and 1. And the SAT will usually refer to that. They don't usually call it exponential decay. They'll refer to it as decreasing exponential. This is probably the most important slide in the whole thing. I would definitely make sure you write this down. Okay, this is not super important on the SAT, guys, but I'm going to go over it anyway because it does come up once in a while. However, you don't have to memorize this. If you ever forget what I'm about to teach you, you can always just type it in like type in the negative signs and see what happens. So don't worry too much about this, but let me go over it anyway. So if you introduce a negative sign in certain spots of a function, it gets reflected. So for example, if I have -2, 3 to the x, the negative sign's in front. That means I have a reflection across the x-axis. So notice how it kind of got flipped underneath, like across the x-axis. If I put the negative sign next to the x in the exponent, it gets reflected across the y-axis. And you might be thinking, well, Kyle, that looks very similar to exponential decay. And you are right, it is. That's because 3 to the -1 is 1/3. So that's another way to write that equation, 2 times 1/3 to the x. And lastly, what happens when you put two negative signs? Well, if I put a negative in front and inside the function, it gets reflected over both axes. And that looks something like this. Like I said, guys, you really don't need to memorize this. You have Desmos, right? So you could always just type in what it looks like and guess and check. If you were stuck, you got a question asking to pick out which graph it was, you could always just type them in and see. All right, let's see what happens when we have exponential decay. Very similar idea. So let's say I have -4.8 to the x gets reflected over the x-axis. That looks like this. If I put the negative sign next to the x instead, it gets reflected across the y-axis. And you'll notice, oh, that looks very similar to growth. And that's because it is exponential growth. 0.8 to the -1 is 1.25. And we would expect a b bigger than 1 to be growth, right? Lastly, if we put a negative sign both in front and inside the function, it gets reflected over both axes, and that will look something like this. Once again, don't have to memorize it. You can always just type these in if you forget. It is kind of hard to remember. Most important thing is understanding when growth and decay happen. Okay, well, we'll talk about this more in a future video. But let's talk a little bit about horizontal asymptotes. So this form changes a little bit if I have a times b to the x plus c. So what is the plus c? Well, let's look at 2 times 3 to the x. That was one we were looking at before. 2 times 3 to the x, you'll notice I added this dashed blue line to show where the exponential gets closer and closer and closer to, but never touches, doesn't cross that dashed line. It's just like a boundary. And that dashed line is we call that a horizontal asymptote, and it occurs at y equals 0. Well, that's because in this equation, there's like a plus 0 kind of hiding off to the side. So you notice the position of the asymptote is the c. So you might want to make a mental note. I don't know how important it is if they'd ask you this, but I think it's important to understand is that the horizontal asymptote will always occur at y equals c when it looks like that, when it's in a form just like that or very similar to that. Now, notice how what happens when I introduce a c. So let's say I have 2 times 3 to the x plus 5. Well, we would look at that, and we would expect the horizontal asymptote to be at y equals 5. And if we graph it, indeed it is. See how it moved up? That blue line is at y equals 5. Now, something happens as well that's a little bit confusing to people. The y-intercept gets affected as well. It also, hopefully that makes intuitive sense. If the horizontal asymptote gets moved, the entire graph gets moved. So, of course, the y-intercept will change. So lots of people, they look at this and they just lock in, oh, the y-intercept is 2 because they think, oh, a is the y-intercept. But as we talked about, that's not always true. When we change the form, sometimes the interpretation of the letters change. So what you should really do is, if you're stuck, is to find any y-intercept, is you should set x equal to 0. So 2 times 3 to the 0 plus 5, 2 times 1 plus 5, and we get 7. So please, 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 if you have any doubt at all, just graph it or set x equals 0 to find a y-intercept. Don't just do this in your head. Okay, let's go over some examples now. So this one says in the question decreases. So right away, I'm going to cross off the choices that say increase. And it also says of its value the previous year. So I can actually compute the multiplier for a 0.86% decrease by doing 1 minus 0.86 over 100. So let's do a little example. So let's say that investment were $50. So the next year it would be 50 times 0.9914. And we get 49.57. And then the next year it would be that times 0.9914 again, and we would get this messy number. The point of this is to just make you realize that it's not decreasing by the same amount each time. It's very slightly different just because it's a small percentage, and it's of the previous amount. So this is not linear, this is indeed exponential, which is choice A. And again, the key word there was the previous year. So this one's a little different. It says increases, so right away I'm going to cross off the ones that say decrease. And now we have to figure out if it's linear or exponential. Well, this one says 4% of its original value. So let's do a little example and see what happens there. So let's say, again, I have $50 and 4% of the original value. So 4% of 50 is 2. So each year it increases by $2. The original value is always 50. 4% of the 50 is always 2, so it's always going to go up by 2. So 52, 54, and 56. You'll notice this is going up by the same amount each time, so it has a constant rate of change. So we're going to call this linear. So the answer is D, increasing linear. Notice the very key and subtle difference between the words previous year's value and original value or initial value. They mean totally different things. Make sure you understand that. Okay, let's see. This one says that the function for every increase in the value of x by 1. Okay, that sounds a lot like it's telling us the multiplier. Remember I wrote that down at the beginning, like on the first slide. So that sounds like it's talking about the multiplier. So I bet this part that comes before it, remember f of x is the same as y. So it says y decreases by 28%. That's just a fancy way to tell us the multiplier. So we can calculate that multiplier using what we know about percents. 1 minus 28 over 100 because it's a decrease. And we get 0.72. So I'm going to go ahead and just cross off the ones that don't have a 0.72 in them. And now they tell us f of 0 equals 28. We can write that as an ordered pair to make it more clear. 0, 28. Oh, that's our y-intercept. So A must be 28. So if A is 28 and B is 0.72, the equation must be 28 times 0.72 to the x, which is choice D. Okay, here they tell us x is the number of years after 2010, and the population in 2010 was 38,000. Okay, so that's the initial value. X is 0. 0 years after 2010 is 2010. So the initial value is 38,000. That means A must be 38,000. So I'm going to cross off the ones that don't have an A of 38,000. And now we're going to try to find B. So it says the population increased by 5% of the previous year. So remember we said that means it's exponential. So that all looks good. So to do a 5% increase, we do 1 plus 5 over 100. So A is 38,000 and B is 1.05. So the equation should be 38,000 times 1.05 to the x, which is choice B. Okay, this one's a little bit more involved depending on how you look at it. So they tell us the initial balance is $8,700. So right away, I'm just going to write down A is 8,700. And I'm going to cross off the ones that do not have an A of 8,700. So let's cross those out. And now we're going to look at the rest of the question and see if we can figure out what B is. A lot of you guys can probably tell what the answer is already, but I'm going to go through the algebra just in case you ever need to do it. So let's go do that on the next slide. So we've got y equals a times b dx. As we already talked about, a is 8,700. And we're going to try to find b. So they gave us this point, which I will write down. 14 years, that's the x or the t, so that's 14. And then the balance is the y value. So we're going to put that into the equation. To solve this equation, we're going to first take care of the 8,700. To move him, we're going to divide both sides by 8,700. And you should get something like this. Now, how do I get rid of the 14 as an exponent? Well, we can take the 14th root of both sides, or in other words, raise both sides to the 1/14th power. However you want to look at it, they're both two ways of doing the same thing. And we should get a b of about 1.03. So the equation is 8700 times 1.03 to the x, or to the t, which is choice C. Now, a lot of you guys could already see, okay, wait, process of elimination, 0.03 would be decay, and the amount is getting bigger, so it must be growth. So you could kind of cross off A as well. Another way you could do it is you could just, regress it on Desmos as well. Just make sure you pick exponential regression, and make sure you put 0 for x for the initial value for the y-intercept. And I also suggest a lot of the time you can click on this little magnifying glass, which will give you a much better zoom, so you can make sure the points are nicely on the graph. That's important. You want to get a good look at it before you lock in your answer. Okay, it's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And I highly encourage you to ask relevant questions about this topic in the comments section. Let's jump to the whiteboard for the final review. Okay, question 1. So this one says that it decreases. Okay, so right away I'm going to cross off the ones that say increasing. That can't possibly be right. And then it says by 3.9% of its original value. We talked about that in the lecture, that the original value is constant. So 3.9% of its original value is also constant, but will go down by a constant amount each year, meaning the relationship is decreasing linear. Okay, question 2. So this one says it is increasing. So right away, I'm going to cross off the choices that say decreasing. And then it says 4.9% of its value the previous year. And as we talked about, if we multiply each previous y value, not the original, that tells us it's exponential because it's changing every time. Think about it. If I start with 5 and multiply by 2 and then multiply by 2, it's going to keep getting bigger. It's not going to have a constant rate of change. So this one will be increasing exponential. Okay, question 3. So this one says it's changing at a constant rate. Right away, that tells me it is linear. Linear relationships have a constant rate of change. So I'm actually going to cross off the ones that say exponential. And it also says that the balloon rises from ground level to 32,000 feet. Okay, so it's essentially going from 0 feet to 32,000 feet. That's getting bigger. So that is definitely growth. So the answer is increasing linear. Okay, question 4. So it tells us that f of 0 is equal to 49. That is the point 0, 49. That is the y-intercept because x is 0. So a in a times b to the x is 49. Now the multiplier, they tell us here, for every increase in the value of x by 1, remember that was in the slides, that tells you the multiplier. The value of f of x, or y, increases by 250%. So we just need to calculate the multiplier for a 250% increase. To do that, we're going to do 1 plus 250 over 100. If you put that into a calculator, you should get 3.5. So the function should be 49 times 3.5 to the x. And that is answer choice B. Okay, question 5. So they tell us this point here, 0, 175. That is the y-intercept because x is 0. That means a is equal to 175. And the multiplier, we see this key phrase here, for each increase of 1 in the value of x, what does y get multiplied by? Well, it says the value of y increases by a factor of 3. Notice how it doesn't say increases by 3. That would be linear. It says increases by a factor of 3. That is just a fancy way of saying it's getting multiplied by 3. So b is equal to 3. So this function is y equals 175 times 3 to the x, a times b to the x. And it says, what is the value of y when x equals 4? So we're going to make x 4, 175, 3 to the 4th. And I will put that in a calculator. And I am getting 14175. And that is the answer. Okay, question 6. So they told us that x is the number of years after 2000, and they told us the population was 50,000 in 2000. So that is the beginning of the problem. That is the initial value. So a is equal to 50,000. To find the multiplier, we see this keyword of the previous year's population. So that's like each year. That's telling us each year y is getting multiplied by some number. And they tell us the number is a 4% decrease. So b is equal to whatever the multiplier for a 4% decrease is. Well, we did that in our percent videos. It's 1 minus 4 over 100. If you put that in a calculator, you should get 0.96. So the function should be p equals 50,000, 0.96 to the x. I'm doing all this without even really looking at the answer choices, so I don't get tricked. And that is looking a lot like answer choice A. Okay, question 7. So, to find the y-intercept, we always just set x equal to 0. So let's do that. So we have y equals 9 times 7 to the 0 minus 12. 7 to the 0 is just 1. And 9 times 1 is 9. So the y-coordinate is 9 minus 12, which is negative 3. So the y-intercept is 0, negative 3. But for the answer to the question, since they just wanted the y-coordinate, we would just say negative 3. This would be good to do on Desmos just to be sure as well. So let's go do that. So I just typed this function in. We see that the y-intercept is indeed 0, negative 3. And you should note that there is a horizontal asymptote at y equals negative 12, the c value. Okay, question 8. So they tell us we have an initial balance of 3,200. That's the initial value, so a is equal to 3,200. Unfortunately, however, they all have an a of 3,200, so that doesn't really help us narrow it down. So the trick to this one is figuring out the multiplier, and it's a little confusing. It's a little different from the ones we've done so far. See how it says the current balance is equal to 90% of the account balance from the previous year. So each previous year amount is getting multiplied by whatever the multiplier is for 90% of. Now, lots of people here would get confused and do a 90% increase or a 90% decrease, but it doesn't say that, right? There's no words that indicate an increase or decrease, it just says 90% of. So to find that multiplier, you don't need to do anything with 1. All you do is divide by 100. So 90 divided by 100, if you put that in a calculator, you should get 0.9. So each year, each y value is getting multiplied by 0.9. So our b is 0.9. So our answer must be choice D. Make sure you read it very carefully. If it doesn't mention anything, any keywords that indicate an increase or decrease, odds are it's not a percent increase or decrease. Okay, question 9. This one is tricky and perhaps a little bit outside the scope of what we covered in the video. However, when you get stuck, especially on a story problem, you can always just come up with numbers and guess and check, and that's what I'm going to do here. So it says the first term of a sequence is 8. Each term after that is 3 times. Okay, 8 times 3 is 24. And why don't I do one more just for good measure? So 24 times 3 is 72. So this is the kicker. Lots of people would call this the 0th term. But that's not what they told you, right? Even if you know nothing about sequences, they told you it's the first term. And they tell you it's the nth term. So if I look here, n is 1 because that's the first term. And then here it's the second term. And then here it's the third term. And they call the actual term of the sequence, they they call that M. So I'll call this guy up here M. And now we can guess and check. So like 1, 8 should be on, satisfy the equation. 2, 24 should satisfy the equation. Okay, so why don't I just go this way up? So if I plug in 1 to the first one, I get 3 times 8 to the 1 minus 1. So 3 times 1, which is just 3. And that is not right. The first term should be 8. So this guy's out. And the next one, if I plug in 1, I get 3 times 8, which is 24. Okay. And then the next term would be 72. And then the next term would be, no, it wouldn't be 72. It would be 24 times 8, which is 192. Okay, so this is already looking way off. C is wrong. Let's look at B. Okay, so if I plug in 1, I get 3 to the 1 minus 1. That is 3 to the 0, which is 1. 8 times 1 is 8. Okay. And then if you plug in, you can just do this on your calculator. You don't have to follow my mental math. 8 times 3 to the 2 minus 1. That's 24. Okay, that looks good. Let's try another one. 8 times 3 to the 3 minus 1. Okay, 72. That is looking good. I bet this is the answer. Let's try choice A just to be sure. Okay, so if I plug in 1, I get 8 times 3 to the 1, which is 24. And then I get 8 times 3 to the 2, which is 72. And then I get 8 times 3 to the 3, which is 216. Okay, so that one is wrong too. It must be choice B. So see, even if you come across a super tricky problem, as long as you can make like a table of a couple values, you're in business, especially if it's multiple choice. Okay, question 10. So this one says it decreases by p% every day, and t is in days, so nothing funny going on with the units. Well, the multiplier is 0.88. That tells me about the percent change, right? So what I'm going to do is I'm going to do a concept we did in percents a whole bunch, is I'm going to take that multiplier and turn it into a percent change. There's 2 main ways to do that. Because it's a decrease, the expression I'm going to set it equal to is 1 minus p over 100. If I subtract 1 from both sides, I get negative 0.12 is equal to negative p over 100. And now I'm going to multiply both sides by negative 100. And I get p equals 12, and that is the answer to the first question. Another way to do that is I go over this in the Ottocento, but also in the shorts, is you can just take the percent multiplier, take away 1, and multiply by 100. It's the same algebra every time. If you can just memorize it, it'll save you a lot of time. So if you did 0.88 minus 1 in parentheses times 100, you should get the same thing. I'll do it on Desmos in a minute. Let's answer the second question. So it says 5 days. So that basically just tells me t equals 5. So it just wants me to find like b of 5. So I'm going to do b of 5 equals 650, 0.88 to the 5. And we're going to round to the nearest integer, the nearest whole number. I am getting about 343, so that is the answer to the second question. Let's show how we could have done this on Desmos really quickly as well. Okay, guys, so I just typed this all in. 0.88 minus 1 times 100 gives us a negative 12% change. That is a 12% decrease. You don't put negative 12 as the answer. You see, if I solve this equation, that's a way you can type it in to get it really quick. I get positive 12. Looks good. And then if you want to find b of 5 using function notation on Desmos, all you got to do is type it in. Okay, question 11. So they tell me it's a basic exponential, so I don't have to worry about like making sure that it is one. I see that x is 0 here. So this value here is a, so a is equal to 400. And now I'm like, x is going up by 1. That is sure is convenient. But I have no idea what the y's are getting multiplied by. I can't really tell. The numbers are too peculiar. So what I'm going to do is I'm going to pick a random one of those y values and divide by the preceding y value. So how about I do 340 divided by 400? And I'll do that on a calculator. And I am getting 0.85. So each time x goes up by 1, this is getting multiplied by 0.85, and you can verify that. That would be a good idea. Be like, if I do 400 times 0.85, do I get 340? Yep. Then if I multiply that by 0.85, do I get 289? Yep. Okay, so the function is 400 times 0.85 to the x. And we're going to do c minus 2d. So that is 400 minus 2 times 0.85. And I'll just do that on a calculator, and I am getting 398.3. That is the answer. Why don't we go do this on Desmos as well? Okay, so I made a table. Now I'm going to click on the regression key. I'm going to set it to exponential regression. And then I'm going to click on the magnifying glass to zoom out. I mean, I can already see that it's 400 times 0.85 to the x, so I can already see that it's C, but how about I export? And if I wanted to, I could change this to C and D. And I can do C minus 2D. And I get 398.3. The fraction would not fit in the Blue Book app, so we have to go with the decimal. It's 398.3. Okay, everybody, thank you so much for watching until the very end of my video. I really do appreciate it. Please comment below your thoughts on the video and worksheet. Did you find them helpful? Be sure to like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.